Hi, and welcome to the BioPharma Finder help videos. In this video, I'm going to show you some of the new features in BioPharma Finder 3.1. I'm going to show you how to build a peptide workbook and how to run a targeted peptide mapping experiment. So on the screen, you'll see some results, and this is from a NIST digest that was pH stressed. And so from this file, I'm going to show you how I can select peptides, modifications, non-modified peptides, things that I actually want to do a targeted analysis for, where I want to select these peptides and then build a peptide workbook, and then I can search that peptide workbook against other raw files. Now, the other reason you might want to do this is in our application, when you're trying to do PTM quantification, where you want to calculate the relative abundance. In our current software, what we have is in 3.1, also in 3.0, and I think a lot of you are familiar with this. We have a mapping tab, and we have where we show the protein sequence coverage. We have the shading plot, and we also have something called Modification Summary. And so if you come into the Modification Summary, this is where you can get kind of an automatic percent abundance of a specific modification. And so the software is going to automatically list the residues and their modifications. So here we have the light chain, we have the M4, and we're looking at the oxidation. Now the software will automatically choose which peptides, which charge states of those peptides it wants to use in actually doing the calculation. So in this case, the ones down below that are highlighted and checked are the ones that are actually used in the calculation. So if we scroll over in the table above, you can see the value here is 0.5%, and that's what's shown over here in the bar plot. Again, so the software is going to automatically pick which peptides it wants to choose, and it has some rules that it actually uses when it selects the different peptides. And so just to show you how this interaction happens, if I click down here, if whatever modification and residue I click above, the chart or the grid down below will change and update. And again, the ones in blue are the ones that are used in the calculation. Now, I think it started in 3.0, maybe 2.0, you could unselect these and recalculate it manually. So you were able to do that if you didn't like what the software chose, or if you wanted to add something else. And when you do that, you're going to get a user-defined value, a customized percent abundance in the table. And then you could also show that value here in the plot. And then you can save that result. Okay. But you'd have to do this every time you wanted to look at that specific modification. So it was a nice workaround, but you would have to change it every time you processed the data. And if you're looking for, this glycation or glycosylation, and you want to know what you always want to use these components, it's a lot of manual work. So the peptide workbook, which I'm going to show you now in 3.1, can help you with that. So in the peptide workbook, you can define what peptides you want to use always, and then you can always go back and search with those specific peptides and specific charge states. Now in the software, when we build a workbook, we can do it many different ways. So I'm going to show you first how we can do it from the Modification Summary, and let's go ahead and do the glycosylation. So we're going to click on, this is the N300 in NIST and the heavy chain, and I'm going to let it use everything. I'm going to check these guys back. Okay, and what I'm going to do is I'm going to right click. And when I right click, I'm going to see Save as Peptide Workbook. I know that the videos, sometimes the pop-ups aren't very clear. I'm trying to fix that, but I can't really figure out why. But what I've done, in case you can't see it, is I've right-clicked in the component table, and I get an option that says Save as Peptide Workbook. And what I'm going to do is I'm going to select the checked. And that's what I'm going to add to the workbook. So I'm going to hit check. Now, let me see if I can get, yeah, there's some kind of memory problem going on here on my computer. There we go. Maybe that'll be a little easier for you to see it. Hopefully you can see this. So what's popped up is the workbook where I can actually write, I can save or create, in this case, the workbook. And so I'm going to create a new peptide workbook, and I have the workbook name, which says NIST pH stressed, and the number of isotopes I'm going to use are going to be 3, and I'm going to hit save. So what the software's done is it automatically has saved this workbook. And there's a new tab in the software where you can click on called Targeted Peptide Workbook. And I'm in the workbook editor right now. I have another workbook open. But if I go to the manager, I'm going to see the workbook that I just created. Okay, and if I double click, you can double click to open things now. Now you're going to see all the peptides that I just added. Okay, so these are those glycosylations, the different glycoforms of the N300. Okay, so we see them all in here. There's 11 of them. Now, inside the workbook, you're going to see some columns. Now, what we did when we created this workbook, if you think about it, we brought experimental data into the workbook. And so for this top glycan, we see the +3 charge state. That's all we saw in the experimental data. Now for the other more abundant ones, maybe A2G2F or A2G1F, we're seeing the +2 and the +3. Now I'm looking in the charge state distribution column, which is showing me the experimental charge states that were observed. Now one thing you might want to do is you might want them to be all the same when you're going to look for all the same, because we hopefully would see the +2s and the +3s. And so what we can do is we can balance the charge states, and we can do that using the add and edit MZ target, add and edit target MZ. So what I'm going to do here is I'm going to say I want you to generate the +2s and the +3s for everything. Now what you have to do is you have to make sure that they're going to be within the MZ range. And so sometimes if I do this and the MZ range is not large enough, or it doesn't go down far enough, you won't see it update. You won't actually get the information in there. So let's leave it like this and see what happens. So again, we're watching the charge state distribution column. Now, if it's the case, this one should go from 2 to 3. So let's update and see what happens. Okay, so it didn't update this guy. So most likely the mass range is not high enough. So we're going to change this to 25. And I'm going to change that to 100. And now hit update. And so now you'll see that it changed. So if you look through here, all of them are now +2s and +3s. Remember, these are glycans. So if you expand, you get the actual MZ information. So you can see that for the +2 for this guy was 1560, and the original value I had here was just 1500. So that's why I wouldn't create it, because it was outside of that range. So now I'm going to save it. Okay? But, you know, I don't want to just look at the glycans. I want to look at something else. So let's go back to our mapping tab. And so again, so in the modification summary, this helps you be able to easily find all the peptides. I'm going to hit yes because we did a custom. And then you could easily find, you know, you can add to the workbook from here. Okay, but let's say, can I add from the process and review page? Let me show you how to do that as well. Okay, so let's go back. So again, you can add from the modification summary. Let's go back to the process and review page. I'm going to add from here. Okay, this is another way, because I'm finding that different people like to use the software differently, so which is really great. Some people like to be in the modification summary. Some people like to be in the process and review page, so I like to be able to add flexibility. Okay, so let's go after a different peptide. So let's look for this M255 on the heavy chain that gets oxidized. Everybody knows this peptide quite well. So I'm going to add, I want to get the +2 and the +1. So I'm just going to check them in the table. And then I'm going to add the +2 and the +1 for the non-modified. Okay. And I'm not going to add the rest because I don't want to use those. So what I'm going to do is I'm actually going to leave them checked, and then I'm going to look for penny K. And what I'm going to do to find penny K is I'm going to click here, and I'm going to say contains in the peptide sequence, and I'm going to write penny K. Now what it's done is it's pulled all the peptides that contain penny K. Okay. Now, I don't like to add the adducts in this case, so I'm not going to include any adducts. So what I'm going to do is I'm kind of lazy, so I'm going to say I don't want to, you know, I'm going to filter those away. And so here I can say does not contain, plus. So now all the adducts are gone. Okay, so I'm going to go through and check these as well. Now remember, I had the other oxidized DTL peptides checked as well. I haven't unchecked those. Now when I get rid of the filters here and here, and I sort, I'm going to see all the things I checked. So it's really neat in the software is you can build lists using the filters and the check boxes. Now something else I want to show you, there's a new column called comment, and I'm going to drag it, also new to 3.1, and stick it over here. Now I can put whatever I want in the comment column, and I can say added to workbook. Okay, and the software is automatically going to save whatever I type in here. I can say, you know, good ID, whatever, and it's automatically updating everything and saving it. And it's also going to put the same information into the modification summary where we just were in the component table at the bottom. There's the comment columns there as well. It's reproduced. Now you can save these results as a different name, but again, it automatically saves the comment information. So the comment column is very powerful. Okay, so we have, remember we created the workbook with the N-glycan. Now we're going to add penny K and the DTL oxidized peptides to that existing workbook. So you can build on to workbooks. So we right click, and I hope you can see the right clicking. I'm going to select the right click option. I'll talk you through it. Save as peptide workbook, and I'm going to select the checked. So I select the checked. Now the window's popped up. In case you can't see it, what I'm going to click on is select existing workbook. This is another option. Now the software is going to show me all the existing workbooks I have. And then I'm going to choose our NIST pH stressed, which has our N-glycan peptides in it. And then I'm going to hit save. And it's going to ask me if I want to it's going to close it because I had it open. I'm going to say yes, go ahead and do that and update it. So now if I go back to the peptide mapping, the targeted peptide mapping, I'm going to see the workbooks, and I'm going to notice that the number of entries increased. And then there's also this group number. So let's open that up and take a look at the group number. What is group number? So what the software tries to do for you is it tries to automatically group these peptides together by similarity. And the group number is actually what is used when you're going to calculate the percent abundance in the targeted analysis. So remember at the beginning when I showed you in a non-targeted experiment, when you were looking at the modification summary, the percent abundance, and the software is choosing which peptides it uses to do the calculation. So it's going to pick the non-modified, it's going to pick the modified, it's going to pick the variety of different charge states, and it's going to, you know, do the math and give you the percent abundance. Well, here you're going to define what gets used, and the software is going to use what you tell it. Okay, so it's a way for you to have control over what's being used in that calculation. So in this case, if we look at group, I have it sorted by group number, relative quantitation group number, and all the glycans, all the EEQ peptides are all assigned to 1. So when the software goes in and we do the targeted analysis, when it's looking at the percent abundance for the glycans, so when it's going to look at the A to G to F, everything that's in a group 1 is going to be used. So the sum of the MS areas of all the peptides components in group 1 are going to be used for the calculation. Okay, so that you're defining the peptides that are going to be used in that calculation. Okay, so in group 2, I have the oxidized form of the DTL peptide, and I have the non-oxidized form. And I'm going to tell it to use the +1 and the +2. Now down below in group 3, those are all the penny K peptides. So I have the different deamidations, and then I have the non-modified, and you can see I'm looking at the +2s and 3s for that. Okay, so now how do you do this targeted search, or what do you do with this? Okay, so what I'm going to do is I'm going to name my experiment. So I'm going to say NIST targeted analysis. Okay, And in this case, what I'm going to do is I'm going to pick, I hope you can see this, but I'm going to pick 4 raw files. So I'm picking a control. Let me go ahead and open them so maybe you'll be able to see it better. Okay, hopefully the screen's updated. Now I'm going to assign the conditions. This is new in 3.1. So I'm going to say control. I have a pH stress, which is what we were looking at. I have a spiked, which has NIST digested with PRTC peptides, and I have an unknown. Okay, so I can just type in keywords and it's automatically going to assign that. Now when I come to select the protein sequence, this is where things have changed. You notice you have a new category. This is peptide mapping, and we have targeted peptide. So you want to pick the workbook. These are our workbooks that we just created. So I'm going to pick the targeted peptide, and then I'm going to pick the default targeted method. So there's a default targeted method. I'm going to choose it, and I'm just going to add it to the queue. I'm going to hit start processing, and it's going to go ahead and it's going to use the workbook that we just created. We have 18 entries in our workbook. We're going to go process this for the 4 raw files, and it's going to go through and look for those 18 entries, and it's going to calculate the percent abundance based on what we tell it, and it's that fast. So now I'm going to open this up. I can double click. Now, because we've done multiple files, we're going to have the new plots that we have in here. I did create a new video called New Peak Detection, and check that out, and it will show you how you can use BioPharma Finder 3.1 to find new peaks that you didn't expect. So it's another YouTube video. So here you can see ratio plots for the different conditions. So we're looking at pH stressed, we're looking at the spiked, and we're looking at the unknown. And there's a feature in the software that allows you to change the reference condition. So in this case, the reference condition is the control group, and it's looking at how these peptides are changing in the different conditions. Okay, the other plot that we have here is MS area, and it's showing you the MS area. Okay, so down below are all the components that we told it, if the software found them, that we told it to go and look for. Okay, so you're seeing all the different forms, the different charge states, and you can see the deamidation should be up in the pH stress, which it is. That's as we expect. Now, let's go to the mapping tab. Okay, now the protein sequence coverage map is going to look a little bit different because we're doing a peptide search now. Okay, so now you're going to see the 3 peptide sequences that we went after. The shading is still going to show you where they are. Okay, so you know you have the chromatographic information. And if we go to the modification summary now, we're going to see the modifications of the specific peptides that we asked it to go after. So for example, so now we're looking at the A2G1F, and again we're looking at the different raw files. So here's the percent abundance. The bar plot shows you the percent abundance. Now, those of you who might not know, you can add the other plots. They're still here. If you want to pull these out, they're just kind of hidden over here on the side. Okay, so you can grab these, and if you want to keep it, you just pin push it down, and it'll stay. Okay, you can see that everything that we told it to use is now in blue. Okay. And if you do update calculation, you're going to get the same value, okay, because they're all being used. These are all the glycans now. And then here's the oxidation. Okay, here's our oxidation on our DTL peptide, and we do expect it to go up in the stressed in this example. And then, of course, we have the different penny K deamidation. Okay, and I think these all go up, of course, in the stressed. Okay. So now what I've shown you is how you can do a targeted analysis and how you're able to use the peptide workbook in BioPharma Finder 3.1 to help you not only go and look in your file to see, target these specific peptides, but it allows you to also be able to control the peptides that are put into the PTM quantitation. so you can clearly define and explain exactly what's been used. And also, remember, you can add this information from 2 different places depending on how you like to use the software. And you can also take the workbook and you can export the workbook, and you can send that workbook to Chameleon for if you're going to do MAM. If you want to do targeted analysis in a compliant solution, that's our compliant solution is Chameleon. Okay, well, thank you very much, and I hope you enjoyed the video, and check out some other videos for the new features in BioPharma Finder 3.1. Thanks.